Hello everyone, this is Yutong. Today I'm going to present our recent work, CoKe, Contrastive Learning for Keypoint Detection. This is a joint work with Angtian, Adam, and Alan. In this work, we introduce a contrastive learning framework for keypoint detection, denoted as CoKe. CoKe uses a contrastive learning method for keypoint detection and detect each keypoint independently. And also, it performs very well on various keypoint detection datasets for rigid and articulated objects. Besides, CoKe achieves exceptional robustness to partial occlusion and previously unseen object poses. To conduct the keypoint detection, we use a contrastive loss to control feature distance. We first minimize the distance of the same keypoint in different images, and then we maximize the distance between different keypoints. Besides that, we also maximize the distance between keypoints and clutters from the background. If you look at this image, we denoted this distance with 3 different kinds of arrows. Here, this is CoKe's pipeline. We first introduce a feature bank, which stores the average keypoint features and clutter features from background, and then we perform contrastive loss on the stored keypoint and clutter to make every keypoint independent from each other and also independent from the clutter. We'll first extract features and do momentum update for keypoint banks and sequential update for clutter bank. And this is an illustration of the contrastive keypoint loss. So we introduce a contrastive keypoint feature loss to control the feature distance. As we can see that we're trying to maximize the difference between different keypoint feature and also maximize the difference between keypoint feature and clutter feature. In this way, our detected keypoint can be independent, and also it can tell from itself and the clutter feature, therefore gives more robustness to its detection. And the inference with CoKe is also illustrated here. In order to detect keypoint from CoKe, we'll first extract features on the target image, and then for each pixel, we can compute the feature similarity of each average keypoint feature from the bank and find the keypoint prediction while the location of the maximum keypoint score. Therefore, we can detect the keypoints and give its coordinates from the inference image. Here we show some results. These are some quantitative keypoint detection results on Pascal 3D Plus, ObjectNet 3D, and also MPII dataset. And also we have some follow-up works. Thanks so much for listening.